added together that would become this once you added them. So in the denominator, and tomorrow we'll do quadratic factors, but today is all linear factors. Your denominators are both linear factors. So essentially we're trying to figure out what over x plus 2 combined with what over x minus 4, once you get a common denominator and do all that jazz to both sides, will become what we have. So decomposition means essentially we're breaking it down and trying to figure out what the two parts were. Sometimes three parts were that added, three fractions were that added together to give us this. Does that make sense? So we're on a quest to find A and B so that we will know what this broke down into. So that is your setup, and essentially we're just going to clear the fractions on both sides. So our least common denominator is this one. So we're going to multiply both sides by x plus 2, x minus 4 on the right, and x plus 2, x minus 4 on the left. On the right, that's going to cancel that completely. So you just have x plus 14. On the left, when you distribute this to the first fraction, the x plus 2's are going to cancel, right? And when the x plus 2's cancel, you're left with a times x minus 4. On your distribution to the b term, your x minus 4's are going to cancel, leaving a b with an x plus 2. And so we distribute your ax minus 4a plus bx plus 2b equals x plus 14. And on the left side, you would then normally combine your x's, correct? So if you combine your x terms, ax plus bx would lead everything, and then you'd have negative 4a plus 2b. A and b are constant numbers of some sort. We just have to figure out what they are so that we would combine them appropriately and get 1x plus 14. So this is where your systems of equations are going to come in. Your x terms that have coefficients of a plus b, in order to match the right-hand side, needs to equal what? How many x's should we be having on the left? 1, right? In order for these to be equal, that's 1x. So a plus b should equal 1. And then your constants should be adding to be what? 14. So they match the right-hand side. So negative 4a plus 2b equals 14. And there's your system. It's only two equations, so it's easier. So we need a multiplier of 2 up top. I'm just going to get rid of my b's. So 2a plus 2b equals 2. Negative 4a plus 2b equals 14. Add or subtract? Good. Two b's both have same sign, so same sign, subtract. Be careful on your first term, the double sign. 2 minus negative 4 is 6a. 2 minus 14, negative 12. So a equals negative 2. We can go back to this layer. I'm going to use the top one. Negative 2 plus b equals 1. Add 2 to both sides. b equals 3. So your partial fraction decomposition, which we set up the structure for right here, we just were on that quest to find a and b. This fraction actually breaks down into negative 2 over x plus 2 plus your b, which was 3, over x minus 4. And we've decomposed that rational expression into two mini fractions with, does that make sense? You would never know negative 2 plus 3 was going to turn into an x plus 14 without that process. But if you were moving forward and someone said add those fractions and you got a common denominator, that would all pan out and it would become x plus 14 over that. So you're just kind of going backwards from what you've always done with rational expressions. Does that make sense? Okay? The next one, we still have linear factors, but one of them repeats. So there are technically 3 factors. There's some a value over x plus some b value over x minus 3 plus some c value over x minus 3. Oh, is it squared? I have to remember if you do the x minus 3 twice. Yeah, you do it like that. So if you ever have a factor that's got a degree on it, and so it's that same factor once or twice or 3 times, you kind of work its way up. You do the x minus 3, and then you work your way up to x minus 3 squared, and if God forbid it was x minus 3 cubed, you'd add a d, and it would be over x minus 3 cubed. You kind of have to step your way up and have one for each degree of it. Does that make sense? Okay? So this all needs to equal x minus 18 over x minus 3 squared. So here is your least common denominator that you're going to be multiplying by on both sides. Obviously, on the right-hand side, when you multiply that, you just are left with x minus 18. On the left-hand side, when you distribute that to the a term, just your x's cancel. So you have a and then x minus 3 squared. When you distribute to your second term, b term, only one of your x minus 3's cancel. So you still have your b with an x minus 3. And with your c distribution, your entire x minus 3 squared cancels, so that's pretty clean, just plus cx. So a little more work here. We want to square this out. So a, and then we have x squared minus 6x plus 9. Plus, we want to distribute our bx, so that's bx squared minus 3bx plus cx. And when you distribute your a, ax squared minus 6ax plus 9a, and the rest. So we have x squared terms to combine on the left, we've got x terms to combine on the left, and we've got constants. What do we want our x squared terms on the left to combine to? Andrew? 0, because we have 0 x squares on the right. So this ax squared plus bx squared, we want a plus b to equal 0. We want those coefficients to add up to 0, so that we have 0x squareds. Our x terms, and I'll box these in, negative 6ax, negative 3bx, and cx. How many x terms do we want, Olivia? 1. So what would be the equation I would write with a's, b's, and c's? You just wouldn't include the x's. You want the coefficients of x's to add up to be 1. So negative 6a minus 3b plus c needs to equal 1. And then the only constant we have is 9a. And that needs to equal what? Negative 18. So a system of 3 variables, but a pretty easy one. Very few, if any, will be as complex as the straightforward systems were last night. When you set these up, you'll find a much more efficient way to solve, which number 1 would be find your a, because that's the easiest. So this gives you a equals negative 2 without much work. once you know a is -2, you can go up here and do -2 plus b equals 0. So what's b? If -2 plus b equals 0, what's b? 2. And if you know a and b, go to your third equation. -6. Is that a negative? Yeah. -6 times a -2 minus 3 times a 2 plus c has to equal 1. And we'll just solve for c. So right now this is 12 minus 6, so 6 plus c. Subtract 6 from both sides, c equals -5. So just make sure you don't stop there. You go up and you actually find what that decomposition was. So it would have been your a value over x, which is -2 over x, plus your b value of 2 over x minus 3, plus your c value of -5. So you don't need to do plus -5. You can just do minus 5 over x minus 3 squared. And you've decomposed your initial fraction into 3 individual ones that would need to be added together to make that x minus 18 happen. I can't remember what it was, but I know I've been curious before and I've explored. It seems kind of funny. Why do you need that term? Like, why couldn't you just do this and this? And if you're curious and you try it, I would try it on the same problem, and you'll see that you'd run into an issue at some point if you don't build up your linear factor to the max degree that it's given to you. It seems like, why would we need that? But you do, and I can't remember how it pans out. But if you did it, you'd see it doesn't work. You'd get stuck. I think you might get down to your system, but it's not solvable for some reason. You're missing too much. So here's essentially the generic format. So whatever your numerator is, and then your denominator, I split up into however many factors there are, and then you just split it up a over b over, I just did a sub 1, a sub 2, a sub 3 over each one of the factors, and kind of go about what we did. And the second case is the case I'm talking about when you do have a linear factor that's being raised to a power. You have to separate. If that was to the 5th power, you'd have to do a over it to the 1st, b over it to the 2nd, c over it to the 3rd, and you'd have to kind of crawl your way up to the 5th power. Trying to think here. In this independent practice, and we won't do these out now so I can get you started on your homework, these just aren't factored yet. So before you get started, you would factor your denominators into x plus 4, x minus 3, and really kind of treat that as your original problem. So you'd have a over x plus 4 plus b over x minus 3 has to equal 5x minus 1 over x plus 4x minus 3. And then everything would be the same that we did on the front side. Yes? Same thing in exercise 2. Your denominator, you'd factor out an x. And then you'd factor the trinomial. And so what would the A, B, C, and so forth setup look like for this one, would you say? Nate, take a stab at it. Well, you need a over and then a factor from your denominator. So what's the first factor from my denominator? Say it again. I'm doing this one. A over x plus b over, what's my next factor? Right, but we have to crawl our way up to the squared. So we're just going to do over x minus 1. And then our next one is going to work its way up from a first degree to a second degree x minus 1. Like that. Do you follow? So if one of your linear factors is raised to a power, you have to work your way up. So you have to do it as a denominator to the first power, it as a denominator to the second power as far as you need, which happens to be done right there. And then we would clear fractions on both sides, set up our system, and solve. Good? And the last one, just looking for the setup on this one. Marissa, take a stab at it. Good. 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 And then you would just clear both fractions with x plus 1 to the 4th on both sides. And it would take some ironing out because when you multiply both sides by x plus 1 to the 4th power, when you distribute over here, only one of those is going to cancel. So you're going to have a times x plus 1 cubed, and you are going to have to cube that out. Then you're going to have b in the x plus 1 squared, which you should be able to square that out in your head. You're going to have plus c to the x plus, or times x plus 1, and then plus d. So that will take a little bit more legwork than we're used to, but then we'll set up the system and so on. Okie doke? All right, I'll throw those examples up on the board.